No.
Not necessary, I trust you. Successful trip on immigration on Friday?
Yeah.
Did you get what you needed done?
Yes.
Then
Half the way. Half the way.
Oh, half a success?
Yeah.
Because you want to get the donuts.
Ah, yeah. Well, that's a key part of going to immigration. Right, Fuan?
Still for
Yeah.
the multiple entry visa.
Alright.
Then I'll be satisfied.
No visa and no donuts? That sounds like a bad trip to me.
No.
A little too big, huh? Yeah, that'll do nicely. Okay, let's do the problems from last week. So what do we need first? Sure, yeah, get the question out there.
Two brackets with different colors.
Exactly, that's what I thought we'd be doing. So just get the question out. Guys, don't just sit there looking stupid. I know you're not. Get out your questions. I think we're going to have a look at the Pascal. No, binomial. Binomial. Very good. Binomial theorem.
Binomial.
Yeah, close. Alright. Binomial theorem. You got that page open? So which question, Faisal?
Top.
You are not Faisal. 3i.
Yep.
Okay.
Yeah, 3i. Or I.
So one question at a time. 3i. So what's 3i?
2 minus 2x
2 minus 2x.
power 3.
Yep.
And then x plus 1 power 5.
And ascending or descending?
First 3 powers of ascending.
It's ascending.
Yep.
No.
Descending.
In descending powers
It's
of x.
It says it in the question.
In descending power of x.
Descending.
Okay.
You can buy that. Right. So we have the first 3 terms. So I don't need to expand fully. I just need to get the first 3 in each. So in each case, whoops. Well, I won't put the brackets in just yet in case I need more space. So this would be 2 minus 2x, with a c.
Can we multiply them?
No, we cannot, because the powers are different. Oh my goodness. Okay. Yes.
Can't we multiply them and add the powers?
Okay, so
That would be really complicated.
I thought you were asking me literally the same question. Just almost the same.
That's what I'm
But the answer is the same. No, we can't.
Okay.
No, we can't either. Where was I? 2 minus 2x, and then 2 minus 2x, and close. And I don't bother with any more because I only need 3. And open. And this one's kind of nice because it's just x and 1, x and 1, x and 1. So I don't need to bother with the 1. So I'll just write cx, 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 because there's a 1 on everything, but that doesn't really matter. Okay, now to put in the powers. So since we want descending powers, we have to start here with 3 on the x, because it says descending. So the x has to be getting smaller. So that's a 3, 2, and a 1. What would this one be? 0, 1, 2. And this one is 3c0, 3c1, 3c2. This one here, 5, 4, and 3. But we don't really care about the 1s because it's always 1. And this is 5c0, 5c1, and 5c2. Okay, 3c0 is 1. This is minus 8x cubed, isn't it? This is 3 times 2 times 4. 24? Isn't it 24? Plus 24x squared. And then 3c2 is 3, isn't it?
Yeah.
3 times 4 is 12. Minus 24, x. Close. This is x5 plus 5, x4, and then 5c2. is 10. 10x cubed. Now, this is where if you're smart...
Wait.
Oh,
But
no,
once you
hang
have
on.
the three descending powers, shouldn't we make the other one? Oh, but, okay.
5-second rule is now in place. Okay, so as I was saying, if we're smart about it, we can save a bit of time here when we multiply. Because right now, how many multiplications are there? 9 multiplications. But we can do less than 9. What will be the biggest power when we multiply? X power 8.
Okay.
The next biggest? And the next? 6. So we only need to do the multiplications that make an 8, a 7 or a 6. And we can ignore the rest. So, the first one here. Will we need to do this one? Yes. Is there anything else that can make an 8? This is the only pair that makes an 8. Okay. The next one. Should we do this one? Yeah, what does it make? A 7, isn't it? So that would be 40x7. Anything else that can make a 7? The 5 and the 2, isn't it? This one makes a 7. So that's plus 24x7. Anything else that can make a 7? That doesn't make a 7, isn't it? So now 6s. So this one here will make a 6.
How many terms
Doesn't matter how many
Uh,
you can only get 3. Because
this
you
one
want
makes a
3
6.
descending powers.
Yeah.
24x.
This one makes a 6. So that's 120x6. And then lastly, this one makes a 6. Which is minus 24x6. So instead of doing 9 multiplications, we can do 6. So we save on doing 3. You only have to do 6. So that is minus 8x8. What's that? Minus 16x7? Yeah. And then that's 20 minus 80 is 40. 16 again? Plus 16. X6. And there are more, but we don't care about them because they ask for descending first tray. So that's an 8, a 7 and a 6. Okay, now I don't know if you could do it as quickly as that when you did it at home, but you realise not too bad now that you've seen it, I think. Okay. So I don't know how many people got this, but I have a feeling most people need to write this down. So if you can write this down now, please. This is okay for him? What's so different about 4i?
Similarly, that is the blah blah blah.
Oh, the blah blah blah.
Or it's find the missing
Oh,
coefficient.
the blah blah blah. Yes,
That one.
that one. Yeah.
4.
Huh?
5 C 0 x to the power of 5.
X, yes. Sorry, that I don't even know. That was a plus. There's ones in there which I'm ignoring. It's 5C0 x5 plus 5C1 x4 plus 5C2 x3. Did you get this perfectly right when you did it?
I know, just.
Did you get it perfectly right? No.
I'm trying to understand it further.
We could be here forever. Just write it down and let the understanding come later. You know, when you're on the bus and you're bored, you can take out the maths book and try to understand it then.
Yeah, sure.
Yeah, good idea, yeah. Do you need me to do 4i? It's the same as this.
No, it's
No,
not.
it's not.
It's not?
It's finding the missing coefficient.
Yeah.
Yeah, so it's practically the same. The only difference is you would have something like a PQ to compare it to at the end.
Yeah.
Yeah. So, well, it was your question. Do you need me to do it? Really? I'll do it then if you do.
I know how to do now. Yeah, okay, you do it. I don't mind.
You don't mind if I do it? Okay, alright. Well, how about we see what other questions people have, and
Question 5.
what's 5 about?
Find the value of PQ and
So 4 and 5 are the same.
Oh no, 5 is much more difficult than 4. Much more difficult. Well, I'll do 4 and 5, but I just want to know what else we need to see.
The next lesson.
What's the next lesson?
Sequence.
Yes, okay. And anything else?
Sounds it?
Okay. If you don't mind, I'll do 4.
Okay.
Yes?
I don't mind.
You don't mind? Good. Alright. Do you write this down?
Yeah.
Mm.
I know.
No, you know. Okay, can I scroll down? You need a minute, or do you have this? I feel like I'm missing one person. Am I? Or that seat is always empty.
But you count your projector.
Yeah. It's all this case or
Doesn't it?
Yeah.
Yeah, okay. Alright. Can I go down to 4 now? Yep. Alright. So, Faran, give me the question. What's the formula? Go on. It's your question.
Bracket
Yes?
P is plus Q.
Yes?
Bracket.
Oh, not again. You know this word.
Not square. It's
Power. Power what? Power
Three.
3? That's called
cubed.
cubed. Cubed, yeah. Cubed, okay. Cubed equals.
No, not equal.
Alright, okay, not equals, sorry, fine.
Multiply bracket
Yep.
s plus 2
Ah,
power 5.
okay. Equals.
S power 8 plus 13 power 7.
13?
13, yeah.
13.
Power 5.
Like this.
Yeah. Plus 73 s power 6 plus blah blah blah.
Blah, blah, blah. Yeah, blah, blah, blah. And we're looking for the P, and we're looking for the Q. So, not really too different. Here, it's going to be 3C0 P cubed X cubed plus 3C1 P squared QX plus 3C2. Oh, sorry, there's a square here, isn't there? Yeah. PQ squared X. Blah, blah, blah. And then this one here is X5 plus 5C. Oh, yeah, well, I didn't even. Why did I even write that in there? Because I know that's 1. Plus 5C1 times 2x4 plus 5C2 2 squared x cubed. Yes. Da, da, da. Now, again, we can be smart about this. Only one multiplication will make the 8. This one times this one will make the 8. So what do we get? We get P cubed x8.
P cube equals 8. No,
Yeah.
P cube equals 1.
Yes. P cubed has to equal 1, which means P has to equal 1 then. Maybe we'll look at the next one to make the x7. So there's 2 that make the x7. What one would that be? The 3 times the 4, yeah?
The 5 times the
And
2,
then, and let me put it in colours here. 3 times the 4, that makes a 7. And then 2 times the 5. Yeah. So that would be P cubed x cubed times x5.
There's another 5 and 2.
Oh, hang on. Yeah, sorry. I need more colours. This one times this one is what I'm doing next. So that's P cubed 5C12 x8 plus, and then this one times this one, plus 3c1 p squared q x, and I wrote 8, of course I meant to write 7, x7. So that's a bit, we know p is 1, thank goodness for that. So 5c1 is 5, 5 times 2 is 10x7. 3c1 is 3, we said p is 1, so that's plus 3qx7. So what have we got here? 10 plus 3q x7. And what should that equal?
13.
So therefore 10 plus 3q equals 13.
Q equals 1.
So q is 1 as well. So p and q are both 1 in this example. Assuming of course they're positive, which I hope they said. No, actually it doesn't, no, p has to be 1, it can't be minus 1, and q has to be 1, yeah. Okay, that one is tricky. In fact, too tricky for the exam in my opinion. I've never seen a question as difficult as this in the exam. But like I said, I like to make the homework a little bit harder than the exam. It's better for you that way. Okay, so write this one down and then we'll look at 5.
What will be our topics for next week's exam?
Everything up to 5 minutes before the exam. But if I do something in the 5 minutes before the exam, that won't be on the exam. Just so you don't have to worry about those 5 minutes. Yeah. Everything else, yes. Good to know these things.
Yeah.
Why can't p be negative?
Because minus 1 cubed is minus 1 and not 1. You need p cubed to be 1. No, there's no silly questions. Only silly people. Oh no, sorry, I got that backwards. Yeah, sorry. Did I? Okay. Will we look at number 5 now? Yeah? Did you write it down? I'll give you a minute to write it down. Number 5 is very tricky. Did some people get 5? You got it successfully? Very tricky. Yeah? Let's have a look at 5. Okay. What is it?
Why didn't that?
Px plus q power n equals.
64.
Yeah.
Minus 96x. Minus 48x squared.
P and Q are above 0.
Great.
Yeah.
Right. First thing, expand on the left. But remember, it's ascending powers. So we'll start with the q being the power n. Okay, so we have
Q are below 0. Less than.
p and q are negative. Oh, okay. Not above 0 then.
Below 0.
You said above 0.
Oh.
I have it on tape.
But I wrote something and I said something else.
Ah, that's okay.
I didn't count to 5.
Qn plus nc1 qn minus 1
P.
px plus, and what's next? nc2 q
N minus.
n minus 2 p squared x squared equals that expression we have on the top. Now we need to do some cleaning up here. Nothing we can do about qn. But what's nc1?
N. 1, 1, 1.
N.
N.
Wow.
Right. So that one's fine. And nc2?
We don't know. We can't know.
We can kind of know. That's the one. N squared minus n over 2. Yeah. Look, NC2, remember the definition. It's n factorial, 2 factorial, n minus 2 factorial, which is n minus 1, n minus 2, n minus 3, etc. over 2 times 1, and then n minus 2, n minus 3, etc. Yep. So you're left with n squared minus n over 2 is NC2. So it's a bit tricky now. N squared minus n over 2. You might want to write that part down because I'm going to go back to the main part. Got that? So when is your maths test next week? I wasn't really listening to Connell. Did he say what day it was? Monday.
Yeah.
Oh, right, so I better get ready for Monday then. And the physics, did he say?
The day after.
Tuesday. Okay. I'm glad somebody was listening. Right, can I go back to the main part? Yes? Okay.
One was physics?
It's good to know someone else wasn't listening. Tuesday it seemed, and maths was on Monday. So the math test and the physics test, I'll tell you it now, since you're all here. You must bring, well, no, you don't have to bring it, but it's recommended you bring your laptop because it'll be a computer-based test. You'll get the questions on Moodle and you type in the answer. You understand? Now, I suppose you could use your phone. It's just, or a tablet, even an iPad. It just feels easier on your computer screen that's bigger. I mean, if you want to use your phone and be doing this, that's fine. But as long as you have something that can connect to the internet, and the test will be timed, and it'll be 1 hour then. Okay.
How many questions will it be?
I don't know yet because I haven't made it.
And marks wise,
What do you mean?
how many? What's the total marks?
It'll be scaled out 100%.
It's always 100%.
I know, but I don't. You're asking me questions which I haven't thought about yet. Yeah.
You have 1 week to think about it.
I do have 1 week to think about it. Yeah. Probably. What I usually like to do is give 1 question for each lesson that we had.
We have an hour.
Yep. I know.
Have more than 15
How many lessons have we had so far? You know,
Chapter wise or lesson wise?
like how many worksheets have? What page are we on? That's how we work it out. What page are we on? 36. We'll do 5 more pages, so we'll probably finish up on about page 46 or something. No, because 2 pages. Don't worry, 2 pages is 1 lesson because you have the answers on the back. So about 23 questions.
How do we answer on the, how do we do on the exam?
We solve on the page.
Answer correctly, please, not incorrectly.
How do we do it?
So we don't have to show them.
Yeah.
No, I'm going to give you some paper to write down your workings. So if you get yeah, because if you get the answer wrong, I'll see what you did, and maybe I'll give you partial credit.
Okay, so the final answer goes
In Moodle, yeah. But like I said, if you got it wrong, I'll check what you did, and maybe I'll think, oh, you were halfway there, so I'll give you some marks then. Yeah. Okay, continuing here. So NC2 we said was n squared minus n over 2, q n minus 2, p squared x squared equals ... Okay, now time to compare. So we have equation 1, qn should equal
minus 54.
minus 64. Number 2, n qn minus 1 times p, that should equal
Minus
96.
minus 96. And then equation, yeah, I'm just looking at the non-x part, the coefficient. And then finally, n squared minus n over 2 qn minus 2 p squared should equal
minus 48.
minus 48. Now, can I scroll down a little bit? Can I, to here is okay? How many things are we looking for? 3. P, Q and N. And how many equations? 3. So it should be possible. What to do next?
The first one. Solve the first equation.
What's the answer? From here.
You get a number that you have the power which equals to 64.
And what number and what power?
The number is 4 minus 4.
Yeah.
And the power is 3.
And how did you get that from equation 1?
Okay.
No.
You use trial and error. But you know that the power has to be real.
So, look at this number. Let's say I have 64 equals...
You wanna use log?
no, I don't. A power b, yes?
Yeah.
You could have 8 squared equals a power b. So a equals 8 or b equals 2.
Yeah.
Or you could have 2 power 5.
But it's minus 64. So you know that b has
Okay,
to be...
fine, fair enough. You know that q has to be negative, but you knew that already anyways.
N has to be
Odd number.
Yeah.
Fine, but my point is still the same.
Yeah.
You don't have enough information to solve uniquely for number 1. There are multiple answers. For example, you could have had n equals 3 and q equals the cube root of minus 64. You could have n equals 5 and q equals the 5th root of minus 64.
Check your answer.
But I don't get what you're saying though.
Okay.
Do you know what I'm saying? You have many, many possible answers here. I never said anything, I never said q needs to be a whole number, an integer. So we can't assume that. Yeah? So we can't do it this way. So any other ideas?
17.
Yeah, but how? How?
Multiply.
Go on. This is going to be good.
Can't we use logs and lns?
Multiply the third equation by 2. Okay. That's the first.
Oh, it's so much easier now. What? Why didn't I think of this a minute ago?
Do something else.
Yes, okay.
After that.
And then after that?
Rearrange to make one of the 3 unknown values.
Which
as
one?
The subject.
Yeah, which one?
Let's say p squared.
Okay, yeah. So I could get the p here. So you get p equals something, yeah?
Yeah.
And then what do you do?
You substitute it and
You'll get 2 values
second
from b.
Second equation.
Whew! And that would work, would make such a difficult equation to solve. Okay. So let's see. Okay. So, sorry, what was this equal to? Minus 48. Okay. So the first thing I'm going to do is I'm going to clean these up a little bit. So equation 1, well, there's nothing I can do there. It's the same deal. Equation 2, I'm going to write it as n qn over q times p equals minus 96. And then equation 3, I'm going to write it as n squared minus n over 2 qn over q squared p squared equals minus 48. So all I did was to split this and this into a fraction. We talked about this last time as well. Okay, scrolling down. A little bit more cleaning up to do. So the first one, not much I can do. The second one, I can change it into n qn p over q equals minus 96. And the third one, n squared minus n over 2 qn p over q squared equals minus 48. Now things are looking a little bit better for us.
So
Substitute the q in the second one.
Yeah, so if you look here, you notice that in both of these you have qn. Can you see that? But you know what qn is. It's minus 64. So you can put this into both of these. And now you'll get just two equations, equation 1 and equation 2, which was formerly 2 and 3. So number 2 becomes n times minus 64 p over q equals minus 96, and now 3 becomes n squared minus n over 2 minus 64 p over q squared equals minus 48. Now it seems like we're worse off because now we have two equations with 3 unknowns, but we can do some more cleaning up here. So watch.
P over Q subject.
No.
Yes, that would work. Yeah. I was going to do some. It's the same idea, but I was going to do something a little bit different here. So what I'm going to do is I'm going to square everything here in equation 1. So now I get n squared, whatever 64 squared is, p over q squared equals whatever 96 squared is. And then here I have n squared minus n over 2 minus 64 p over q squared equals minus 48. And now I wonder if anyone can see what to do next.
3 and 8
Yes.
n squared.
Well, divide them. Divide them. So the next thing I should do now is take equation 2 and divide it by equation 1. So now I'll get n squared minus n over 2n squared. Then I'll get 64, sorry, I want to make sure I have it the right way around. 2 divided by 1. N squared minus n over 2 divided by n squared. Minus 64 divided by 64 squared. This divided by this, they cancel. Minus 48 divided by 96 squared. So that becomes n squared minus n over 2n squared. 1 minus 1 over 64 equals minus 48 over 96 squared. So that becomes n squared minus n over 2n squared equals 48 over 96 squared times 64. Minus is cancelled on both sides. 48 divided by 96 divided by 96 times 64. That's a nice 1 over 3. I'll bring the 2 across as well. So 2 over 3. N squared minus n over n squared equals 2 over 3. So that means 3n squared minus 3n equals 2n squared. So that means n squared minus 3n equals 0. N, of course, can't be 0. So n equals 3. And then, once I have this answer, I take it back to the very, very first one here. So you're looking for q cubed equals minus 64. So, what's that?
Minus 4.
Minus 4. 4, 16, minus 4. And then what can give me the p?
Minus 2.
Is there anything nice to give me the p? Something like this one here. Let me just write it down. N Qn p over q equals minus 96. N is 3. What did I say this one was? Q. Minus 4 cubed is minus 64. P is q is minus 4 and p is what we want. So if I just grab the calculator here, I can get the p. Minus 96 divided by 3 divided by minus 64 times 4.
Minus 4.
Minus 4. Minus 2 for p.
Yeah.
P equals minus 2. I told you it was very hard. I wasn't lying. but for the wrong reason. But for the wrong reason. Okay, write this down. I'm sure not many people got it. What?
Trump is the president for the wrong reason, but he is.
That's true. That's true. But unfortunately, there's no democracy in maths. There's just right and wrong. Question? No. Did you write this down? Good. Yeah. We'll have a look at sequence next. You had a question on sequence.
Question 6.
6. Is that the last one? Okay. Write this down, please. Is this okay? Are you sure? Don't lie to me. It's not easy. Is it easy?
Like this question, it don't have never been Chinese math before.
Why? Because it's too easy? Okay.
And there,
Okay, show us one of the
Okay.
questions in the Chinese.
Show us the Chinese.
Yeah, write the question.
Give us an example.
like a type.
Right.
No, leave him. Leave him. Don't trust him. Look at him. How could you trust him?
Show me, I want to see.
Don't trust him.
What kind of?
The same topic.
Don't trust. You see, you're trusting him. You're too trusting.
I think he's actually telling the truth.
All right. Sequence. Next question. Can I scroll down?
Which type of sequence?
Yeah. Question 6. Can you read the question, Florence? Yes, you can. Go for it. Go on. Be brave. Do you have the question?
Question.
Yeah. Give it to her so she can read it. Go ahead. I know you love to practice your English.
No.
Yes. Go ahead.
Where's sequence?
Yeah.
Wow.
Go.
Graph the sequence un equal 1 over n squared and the sequence v. Yeah. Why you know that?
I could sense it.
Okay. V n over bracket 1 plus. Yeah, right? Where v1 equal 1. Comment on the graph.
Okay. So I just want you to make the graph here for these. So we'll put them on the side. Well, this one is easy. U1 equals 1. U2 equals
Half. 1.
1 over 4. Faisal. U3
1 over 6.
1 over 9. And U4
1 over 16.
Right, here V1 equals 1. V2 is it?
2 over 1.
Yeah, well I want to put in the formula so we can do it automatically. Okay, so we have fraction, answer over bracket 1 plus answer squared, like, oh no, sorry, there's a square root here, isn't there? Like this. Yes?
Yep.
So the next value is a quarter. And the next value is a ninth. And the next one, you won't be surprised to learn, it'll be a 16th. So the point I was making with this question was that although they look very different, they're actually the same sequence. And when you graph it, you can see it as well. So here, the way you graph a sequence, you put n here, u here, n here, vn here, un here. And you usually do it as a bar chart. So we'd have 1, and then the next one is a quarter, a ninth, a 16th, and the same here. Okay. Is that okay? Oh dear, I'm dying.
That's the
Yeah, I need it in this class. Alright. Now, that's it. So, it's an interesting question. I made it just so you could see that you can't always tell from the formula what you're going to get. Don't judge a sequence by its formula. You have no way of seeing that the recursive sequence on the right would make the same sequence as what's on the left. And then, if I was to change this to 2, would you get the same sequence? Would it be different? Similar? Well, as a matter of interest, let's see what you would get if you put in 2. So if I put in 2, and then we go back, you get this instead. And then this, and then this. So very different sequence. Although it's still convergent to 0. Can you see that? Yeah. I wonder what happens if I start with 0. Oh, I know what happens when I start with 0. What happens when I start with 0?
Nothing.
What do I get? No, I don't get an error.
Get 0.
Not error.
0, 0, 0, 0, 0.
Yeah, 0 all the time.
0, 0, 0.
Yeah, because it's because of the top. Yeah. Okay. Okay. I think we'll leave it there. Yeah. But I don't think there were anything else. Was that the only question you had from it?
For sequence of the bar chart, the old bar chart.
Yeah, the other point I wanted to make with this question is when you graph a sequence, the graph you should use is a bar chart for a sequence.
Always.
Yeah, it doesn't look right to me to have something else. It should be a bar chart. That's important information for your coursework. Dude with his head on the desk. Great. You get that important piece of information?
Yeah, I was just saying it to myself.
You were letting it wash into you, yes. Okay.